Beyond the different types of facial recognition, how we extract the facial vector, there are additional technology considerations for ensuring high accurate facial recognition. Let's review some of those variables in optimal face recognition. So many cameras parameters influence the level of the accuracy of your facial recognition deployment. The first one is camera type. There are many camera types with different benefits, such as cameras that can cover large field of view, like fisheye or multi-sensor cameras, and cameras that are sensitive to non-visible light and can be used in the dark, for example, infrared or thermal cameras. These cameras typically produce video with less data that's available and relevant to support the facial recognition algorithm. As a result, the accuracy could be lower compared to standard color cameras. The camera placement. So a facial recognition algorithm works best when the face is clearly seen and the minimum pitch and yaw, as those distort the face when alignment is performed and may hide some of the facial landmarks. This means that the shallower the angle of the camera towards the ground, the better, and when possible, target objects should walk towards the camera directly. Ideally, without occlusion, then nothing drops. Cameras should be placed in such a way that light sources are behind it and not in front, as this may decrease the exposure time, and that's also called as shutter speed. And it makes the image darker, depending on the camera's dynamic range. So when your dad told you to always have the sun behind you when you were taking a family picture, he was right. Most cameras' lenses can be adjusted. It's recommended to adjust the focus point of the camera to the approximate location or depth people are expected to appear in. Lastly, make sure the camera is properly fixed and does not move because of wind or because it's mounted on a shaky fixture. That's one of the key variables to keep in mind when it comes to accuracy. Now, it's not the overall resolution of the camera that always matters. What's important is the pixel count of the faces themselves. If people are walking very close to the camera and most likely will have sufficient face resolution. However, if the field of view is very wide, for example, a camera that overlooks a busy junction or an airport terminal, then each person will be relatively small in the frame, and therefore a high resolution is required. BriefCam face recognition technology requires faces of at least 24 by 24 pixels, which is equivalent to 12 pixels between the eyes. Frame rate is measured in frames per second, or FPS. BriefCam tracks objects as they move throughout the scene and chooses the best snapshots of the face. The higher the frame rate, the more selection BriefCam has for the best shot. To get the maximum contrast of the facial features in the video, a good illumination should be considered. It can be either natural or artificial light, but the less shadows and the more frontal lighting is available, more facial features will be detected. Bitrate is one of the most confusing elements in digital video. People tend to think that the higher the resolution, the better the video quality is, but it's not necessarily true. Video compression is built on the foundations of removing excess data from the screen, and different levels of excess data can be configured. So a 4K video resolution can be configured to consume little bitrate, and the result would be a video with all of the 4K pixels, but each pixel's reliability to the source is low. People in the video can move slowly or quickly. It doesn't necessarily mean that they're running. The camera could be too close and they'll pass by very quickly. But if that happens, smearing effects can occur due to how cameras' CCD sensors work. Also, there will be less frames to choose from. It's advised to balance the camera's distance to the object so it's not too close and not too far. So let's discuss the facial recognition working point. There are two important terms when looking at a benchmark. False acceptance rate, or FAR, also known as false positives, is when the system detects that the face is a match when it isn't. False rejection rate, FRR, also known as false negative, is when the system decides that the face is not a match when it is a match. There is a need to balance between the two for optimal results. Any facial recognition algorithm can produce excellent results on one parameter on the expense of the other. That balance, or the working point, depends on the use case itself. If we want to get less false alerts, it automatically means we will detect less of the people on the watch list. If we want to minimize misses of watch listed people, we will automatically get more false alerts. With well-balanced algorithms, the curve will be more to the top and to the left of the graph. The working point can be configured through tolerance control in the BriefCam software. One industry-accepted standard dataset for facial recognition is IJB-A. The dataset was created by NIST, that's the National Institution of Standards and Technology, and it is based on public data. The images on this dataset are celebrity photos taken from various media outlets and are mostly constrained, meaning they don't always look like a person would look in a surveillance camera. Remember, we discussed variables such as pose variation, low resolution, facial expression, different hairstyles, illumination changes, blurriness, and occlusion for quote-unquote in the wild images. Another dataset used in this test is LFW, which consists more of unconstrained photos, but still not exactly like objects are seen in surveillance video. So BriefCam has created several diverse benchmarking and training datasets that resemble to how people look in typical surveillance video. By that, we ensure we test our networks just like they'll be used in the field. Each dataset is then annotated manually with quote-unquote ground truth data. So every time BriefCam releases software, it is automatically tested against this ground truth dataset, and the accuracy is quantified and compared to previous releases. This enables high accurate results for in-the-wild facial recognition.